Hi, Lesson 9 today is about tables of equivalent ratios. Our classwork example reads as follows. To make paper mache, the art teacher mixes water and flour. For every 2 cups of water, she needs to mix in 3 cups of flour to make the paste. Find the equivalent ratios for the ratio relationship 2 cups of water to 3 cups of flour. Represent the equivalent ratios in the table below. Now, before we get started on this, let's talk a little bit about what we're going to be doing. First off, what does the ratio mean for every 2 cups of water, there are 3 cups of flour? What does that mean? Well, it means every time we have a set of 2 cups of water, we need to have a set of 3 cups of flour. Okay, so why is it worded for every 2 cups of water, there are 3 cups of flour? Why do they choose that particular wording? Well, this suggests that we might be doing the action repeatedly. We might be making more than one batch of the mixture. And then we'll be adding 2 cups of water and 3 cups of flour every time we needed to increase the amount of paper mache. Okay, so why might I need to increase the amount of paper mache, the mixture of paper mache? Why would I need to increase that amount? Why couldn't I just keep it at 2 cups of water and 3 cups of flour? Well, if the teacher had a classroom of just 10 students, she might only need to have the 2 cups of water and 3 cups of flour for the paper mache. Whereas if she had a classroom of, say, 25 or 27 students, she would definitely need more than that to go around to everybody. So she would need to increase the amount of mixture that she has. All right, so let's move on over here to this table. Let's see if we can fill out the table. So is there an equivalent ratio that uses smaller whole numbers than the ratio 2 to 3? Let's see what I'm talking about. So we have 2 to 3 cups here. If we wrote that as such, is there another way that makes this a smaller amount of numbers? If we were looking at it as a fraction, it would be, the value of it would be 2/3. Is there a way of simplifying 2/3? No, there's not. So that being the case, that has to be where we can start off with. So let's put 2 inside here for cups of water. And 3 for cups of flour. All right. What would the next possibility be? If we were to make another batch, we wanted to have enough for twice the batch. Well, if we wanted to make another batch, we would have 2 more cups of water, so that would make a total of 4 cups of water, and 3 more cups of flour, so that would make a total of 6 cups of flour. Now, if we were to continue this ratio, what would the numbers be that you put inside here? If we made another batch, if we needed to make an additional batch, so 3 batches instead of 2 batches, and then 4 batches instead of 2 batches, and then 5 batches instead of 2 batches, what would the numbers be that fit in here? Okay, what is the value of each ratio in this table? Remember that value means what is the ratio written as a fraction? Well, this one is 2 to 3, and so we write that as 2 to 3. This one is 4 to 6, but can that be simplified? It can. If we divide the numerator and the denominator, by 2, that would then be 2/3 as well. What about 6 to 9? Let's write that over here. Can you divide the numerator and denominator by a number to get a different number? Sure, we can divide top and the bottom by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Huh, so that one is 2/3 as well. What about 8/12? Let's try that over here. Can you divide something by the numerator and denominator by something to get another simplified fraction? Sure. We could divide the 8 and the 12 by 4. 8 divided by 4 is 2, and lo and behold, 12 divided by 4 is 3. So this one ends up being 2/3 in its simplest form. And the last one, 10. I can't write it over there. I write it up here. 10/15. What can we divide this one by? Oh yeah, we could divide both by 5. 10 divided by 5 equals 2. And 15 divided by 5 equals 3. So it looks like the value for all of these are 2/3 in its simplest form. Huh, look at that. It's all 2/3. So if we were to look at it again, we could say that all of these ratios, when we write the value of each one and we simplify it, comes out to 2/3. Very interesting. What we've created here is called a ratio table. It's a table in which all of the ratios are equivalent to one another. Here it is written down. Go ahead and pause the video and write it onto your paper so that you have a definition of a ratio table. Hi, this is example 2. Javier has a new job designing websites. He is paid at a rate of $700 for every 3 pages of web content that he built. Create a ratio table to show the total amount of money Javier has earned in ratio to the number of pages he has built. Okay, well, let's see what we need to do. First off, this is about what? Javier has a new job, and his job is designing websites. And when you design a website, it's called building a page. So he gets $700 for every 300 pages of web content that he builds. So my first question is, if we start to fill out a ratio here, our ratio table, is there an equivalent ratio, 700 to 3, that uses smaller whole numbers than 703? You really, if we put those into talked about the value of it in its fraction form, you really couldn't reduce that. You couldn't simplify that. So let's start with 3 and 700. Okay, so this means he builds 3 pages, he gets paid $700. What happens if he builds 3 more pages? So he builds 9 pages. How much money will he then make? And then I want you to continue filling out this table and with all the numbers. All right, well, based on our ratio table here, we find that for the first 3 pages, he makes $700. For the next 3 pages, he will have completed 6 total pages. He will have made $1,400. When he completes 3 more pages, bringing that total to 9, he will then be earning $2,100. And when he makes the next 3, which would be 12 pages, he will then be making $2,800, and then so on. These are the numbers that you should have come up with. Do you notice any pattern in the table? Well, looking at the next question, it says, Javier is saving up to purchase a used car that costs $4,200. How many web pages will Javier need to build before he can pay for the car? Okay, I suspect you're getting the hang of this, and so I'm going to read this one and then let you head off on your own to fill in the ratio table, and then we'll come back and you can do the questions too. Spraying plants with cornmeal juice is a natural way to prevent fungal growth on the plants. Didn't know that. It is made by soaking cornmeal in water. using 2 cups of cornmeal for every 9 gallons of water, complete the ratio table to answer the questions that follow. Well, now I know how to make that too. Okay, go ahead and fill in the ratio table, and then we'll come back and see if you got the right answers. Starting with the lowest one here, the lowest in terms of numbers, and then continuing on. Well, here is what the ratio table looks like. For every 2 cups of cornmeal, using 2 cups of cornmeal for every 9 gallons of water, we have written as 2 to 9. And if we made 2 more, we had 2 more cups of cornmeal, we would need 2 more gallons of water. That would make it 4 to 18 for a total. If we then went on and we wanted to put 2 more in there, we would then have 6 cups of cornmeal for 27 gallons of water. And then 8 cups of cornmeal for 36 gallons of water. And then 10 cups of cornmeal with 45 gallons of water. Okay, now that we have that information, we can go on to answer the next questions. How many cups of cornmeal should be added to 45 gallons of water? All right, and the next question says, Paul has only 8 cups of cornmeal. How many gallons of water should he add if he wants to make as much cornmeal juice as he can? Well, let's make a copy of our ratio table so that when we move down, you can still see it. And let's move it on down. And then we may not need it, but it's good to have it nearby. Paul has only 8 cups of cornmeal. How many gallons of water should he add if he wants to make as much cornmeal as he can? C says, what can you say about the values of the ratios in the table? Well, you have to figure out what the values are in order to answer that question. All right, exercise 2 says, James is setting up a fish tank. He is buying a breed of goldfish that typically grows to be 12 inches long. It is recommended that there be 1 gallon of water for every inch of fish length in the tank. What is the recommended ratio of gallons of water per fully grown goldfish in the tank? Take a minute to fill out your ratio form first, your ratio table, and then you can start answering the questions, but let's do the ratio table first. All right, so this one was a little bit challenging because the ratio there, you had to go back and really look at it. That goldfish, because goldfish grow about 12 inches long, 1 goldfish is about 12 inches long. So where it says it's recommended that there be 1 gallon of water for every inch of fish length, if there's 1 goldfish, that means there should be 12 gallons of water. That's where we have our first numbers. From there on, we can move on. If there's 2 goldfish, that means we need to, the inches increase by 2, and that means our gallons of water have to increase by 2. If we add another goldfish, then we need to increase it by 12 to make it 36 gallons of water. A 4th goldfish will increase it to 48 gallons of water, and a 5th goldfish will increase it to 60 gallons of water. So that's where these numbers came from. Take a minute and let's answer the questions now. What size tank in gallons is needed for James to have 5 full-grown goldfish? Okay, how many full-grown goldfish can go in a 40-gallon tank? And I've just taken this and put it back here, copied and pasted it so you can see. Well, C says, what can you say about the values of the ratios of the goldfish? Sorry, what can you say about the values of the ratios in the table? So if we were to turn these into, find the values, and then simplify them, what can you say about that? So today's lesson summary is fairly easy. A ratio is a table of pairs of numbers that form equivalent ratios. That's basically all this was up here. Were pairs of numbers, and the ratio were made equivalent ratios. Let's get ready for your exit ticket. Well, your exit ticket is a father and his young toddler are walking along the sidewalk. For every 3 steps the father takes, the son takes 5 steps. just to keep up. What is the ratio of the number of steps the father takes to the number of steps the son takes? Add labels to the columns of the table and place the ratio into the first row of data. Add equivalent ratios to build a ratio table. So go ahead and put your title here, your label here, and then your label here. You need to then add ratios 1, 2, 3, 4, 5. 5 after the first one that they give you. Okay, so there's your exit ticket. When you're done, what can you say about the values of the ratios in the table? Just what we've been asking you before. What can you say about the values of the ratios in this table? Okay, and I'll leave it here so you can see what you're doing.